Okay, hello TAM 210 to 11 students. This is Professor Kirsch. I'm just going to do a quick video where we go over some of the concepts in the last couple days regarding moments, moments about a point, moments about a specific axis, and then we'll finish up with force couples. So hopefully this will help clear up some of the questions that were coming up in lecture and on Piazza. So first, what I have here is just set up in general that moment of a force about a point means that we're looking at the tendency for rotation. And in general, that is the definition for what the result of a moment is. And so it's correct that when we consider the moment about a point, we have to know what axis or what point we're taking this with respect to. So let's say we have our generic blob here, and we have a point A that has some force applied, Fa, and maybe there's even another force acting at some other point B. Just keep those in red here, and let's say there's this force here. And so I've already defined points A and B over here on the right, and we know that if we want to calculate the sum of the moments with respect to the origin, then we need to know the moment arm vectors. And those are going to be, of course, going from O to A, and then from O to B, and then we can sum all of this up, right? So mathematically, we're going to have two contributions to the moment due to the two different forces, and those are going to be the result of the cross product between the moment arm vectors, ROA and ROB, we'll label point B here, and the forces, FA. So remember, each of these are vectors. And the important, but sometimes difficult thing to believe is that we can take and get this moment can be calculated with respect to any point along the line of action of the force. So this can be from the point O, the point of origin, to any point along the line of action of the force. So I'm going to do a quick example to prove to you why that's correct. Okay, so here we have our blob again, and now I very deliberately calculated this so that we know what the moment vector R is and what the force vector Fa is in terms of its components. So we're going to do this numerically. In class we showed this symbolically, but maybe having a numeric solution will help some of you. So this R vector has components 7 in the x direction and 3 going up. And then it has a force A of components 2 and 3, right? So this is the components, and now we can do the sum of the moments. Let's say about O is going to be equal to R cross F. And we know that that's going to be using the determinant. So this is only a 2D problem, 7, 3, 2, and 3. And so when we do the cross multiplication, 7 times 3 is 21, minus the 6 from this cross multiplying will get us our 15, whatever the units are. In this case, let's say Newton meters. So this should say meters, and this should say newtons. And now let's see if we move the line of or take the moment with respect to the line of action of the force at a different location. So I'm going to draw this so that it intercepts with the x-axis. So the components of the force are still the same, but now we have a new moment arm vector. So it's not this moment arm vector anymore. I'm going to take this new moment arm vector, R, here, which just so happens I've set up the math conveniently, but again, you can do this with any problem, such that the components of R are going to be equal to 5 and 0 meters. F still remains the same, right? F is just a vector, right? Going from 2, has components 2 and 3 newtons. And so now, when we take our sum of moments about O, we again are with R cross F. which is going to be the determinant of 5, 0, 2, and 3 this time. And you see, hopefully fairly quickly, that you get the exact same answer. So this is 15 Newton meters again. So here, it doesn't matter where you want to take this moment. You can use any R. Now, why would you do this? It might be that sometimes you know this vector, but you don't know this one. Or you know this one here or this one here. It just depends on what's given to you in the problem. But this is really convenient, right, in terms of solving for these. So that's moment about a point. I'm going to pause and actually start a new video to do the moment of a force about a specific axis.